Good evening. For this example right here, what we are talking about is whether or not these functions are inverse functions. So we want to know if on number A, f of x equals 2x plus 5 and g of x equals x minus 5 over 2 are inverses of each other. Okay, so that's what we want to know, inverses of each other. And one of the ways that we can do that is by using composition of function. So if I do f composed of g of x and I get x, that means that they're inverses of each other. I can also do g composed of f of x, and if I get x, that means they're inverses. If I get anything other than x, they're not inverses of each other. Okay, here's part B, f of x equals 2x and g of x equals 2x. So we're going to do both of these. So let's look at the graphs first. Okay, so I want you to look at these graphs right here. The first graph that I'm looking at is this blue graph, 2x plus 5. Or I'm sorry, I'm not looking at the blue graph first. I'm sorry. I am looking at the red graph first. Apologize about that. 2x plus 5. So the red graph is f of x equals 2x plus 5. So let me write that down for you. So that's f of x. Okay? Now we are going to look at the blue graph. The blue graph is g of x. Okay? Now, the green line right there, that's just y equals x. Let me get a green. I don't have a great green, but this is just, that line right there is y equals x. And if you took this and you folded it, f of x and g of x would be on top of each other. They're inverses of each other, okay? So when we look at this, we can see that they're inverses, but we want to prove algebraically that they're inverses. So I am going to do f composed of g of x, okay? F composed of g of x. So what that means is I'm going to take g of x and I'm going to plug it into f of x, okay? That's what I'm going to do. So I'm going to take this x minus 5 over 2 and I'm going to plug it into that x right there. That's what I'm going to do. So I've got 2 times x minus 5 over 2 plus 5. Okay, so I have done f composed of g of x. So my 2's right here, they cancel. Okay, so I'm left with x minus 5 plus 5. Okay, and I end up with x. Okay, now we can tell by the graph that they're inverses, but also when I do f composed of g of x, I get x, and that's the definition. When you do composition of functions, you get x. Now if you get anything other than x, they're not inverses. So let's look at the next one. Here I have f of x is 2x, and I have g of x is 2x. So I want you to look, and the reason that you don't see these extra lines is because both of these are this line right here. They're on top of each other. The green line, again, is our identity line, okay? So this is y equals x. And if you folded this line right here, you're not going to get lines that are on top of each other. So let's do f composed of g of x. Now remember, if functions are inverses, when we simplify f composed of g of x, then we're going to just get x. So this is the same thing as f of g of x. Okay, so I am going to do 2, and instead of x, I'm going to put in the 2x. Okay, and 2 times 2x is 4x, and that is not x. Okay, it's not x. even though we get 4x equals 4x, that doesn't mean anything. We would have to get just x to find out if they were inverses of each other. Now, sometimes looking at the graphs help. Okay, so that's why I did the graphs, to kind of show why they weren't inverses of each other. Okay, so look over that. Let me know if you have any more questions, and don't forget to send me a screenshot. If you need a screen, or if you want me to work something out, be sure I get a screenshot. Thanks.